Okay. So, anybody want to take a guess at what a multinomial experiment is? What was binomial? Do you remember? Two options. Okay, so a multinomial is many options. It could be three or more. So, an experiment with three or more possible outcomes. Remember that this is pronounced chi, square goodness of fit test, and it is used to see whether a frequency distribution matches an expected distribution. Okay, now they had a nice little bit in our textbook that I decided to just paste right in. So it says, to begin a goodness of fit test, you must first state a null and an alternative hypothesis. Generally, the null hypothesis states that the frequency distribution fits, and an alternative states that it does not fit. So the null says that it fits, and the alternative, can't spell words today. The alternative says that it doesn't fit. Okay. For example, an association can claim, and this is their claim, that the expected distribution below of people who use different methods to prepare their taxes is shown below. So 24% of people, this is their claim, remember. This is their claim that 24% of people use an accountant, 20% of people do their tax by hand, 35% do it by computer software, 6% do it by a friend or family member, and 15% use a tax preparation service. Do you guys know how your parents do your taxes? Themselves? Do they do it by hand, or do they do it by like a computer program? By hand. Anybody else know? Computer program. Anybody else? Anybody do taxes themselves? Okay, taxes are pretty easy if you do not have a lot of wealth. And not just wealth, it's more like investments, like if you don't have stocks or stuff like that, you don't have children, you don't have a house yet, like the first few years of you guys doing your taxes, you're gonna be like, so I add and subtract and then get a refund? Why are people complaining about this? And it gets tougher, especially if you like own your own business and stuff like that, but at the beginning it's pretty easy. Okay, so the observed frequencies is the percentages from the sample data. I'm sorry, not percentages. It's going to be a number. And the expected frequencies are the numbers that you expect. To find those out, you might have to take a percent times your n to find out your expected frequency. Okay. So for example 1, all we're doing is finding out observed frequencies and expected frequencies for each tax preparation method. And remember that this is the claim up here, so we're actually using info from this one up here for this problem. So we're going to start with expected frequencies. Here's what we expect to have happen. Do you guys remember the difference between a frequency and a relative frequency from back when we were making like graphs? Go ahead. Right. The frequency is just how many, right, of something, and then the relative frequency is what that percent is. That's where I was getting mixed up with my definition up here earlier. Okay, so our expected frequencies, we need to find one for an accountant, doing your taxes by hand, doing it with a computer, family and friends, and a tax service. And then we're also going to find the observed frequencies for all of those as well.
What's the acronym?
Family and friends and family up here. Okay, so to find the expected frequencies, all you do is you list you take the percent that you expected to have and then multiply it by how many people you asked. So it looks like they asked 300 adults. So on your calculator, you're going to take that 24% of accountants and multiply by 300.